Thanks so much for being here. My name is Cedric Clyburn. We've got a big session here in the next 50-ish minutes that I want to go with you guys for. So today we're talking about going from containers to pods to Kubernetes. And we're going to be talking about the various tools and technologies and open source projects that we help create here at Red Hat to help with managing, working with containers, and ultimately deploying to Kubernetes environments and streamlining that workflow. So we're going to see everything in action today here that I talk about. I'm going to be doing it here on my Mac machine, building multiple containers directly from my VS Code environment, doing that on Podman Desktop to run the containers, debug those containers, work with multi-container applications, things like Compose as well, to then transform those into pods, which is a grouping of one or more containers, a Kubernetes resource, the most basic unit, then take that to a local or remote Kubernetes environment like Kind or Minikube and deploy it onto a Kubernetes cluster so I can share it in the Devnexus Slack here and you guys can see the application running as well. So who's ready to get started? Woo! All right, awesome. And before we get into the bulk of the presentation, I just want to say being at Devnexus is really a pleasure because this was the first ever conference I ever went to. Here is me, like 3 years ago. I had my first opportunity to speak ever. This was a talk about containers without Docker. And I think it's really cool to see the progress of projects like Podman. And we're going to see like the support and how we've streamlined a lot of workflows and see the new project Podman Desktop, which came out last year, all in action. So I'm really, really excited to be here. And I kind of want to give a huge round of applause to Pratik and Vincent and everyone on the Atlanta Jug for making this event possible. So they've done a great job with this conference. The best conversations, the best people here. So thank y'all for being here. What we're going to get into today is we're going to first, to get to Podman Desktop, we have to talk about Podman as a container engine itself. So before we even get into Podman, I want to talk about some of the various reasons that I care about the project, and I think that you should care about it too. So typically when I talk to developers and I talk to teams, they tell me they have a number of issues. For example, they've been impacted, this might be you, by the Docker licensing changes that came about in 2022. And maybe your IT team has asked you to maybe migrate off of Docker, find a different solution. Maybe you're in some kind of large organization, security conscious organization, banking, financial services, where you need to be able to run containers in a rootless fashion by default. You need to be able to focus on security, take advantage of different Linux kernel features like SE Linux. You want to be able to take advantage of container technology, but you can't yet. Maybe you don't need a full-scale Kubernetes cluster, but you want to be able to run containers in development and production purposes with different lifecycle management tools, auto updates, rollbacks, things like that. Or maybe you're new to the world of Kubernetes. It is daunting, trust me, but you want to be able to run pods and deployments in different Kubernetes YAML without a full cluster, without standing up a full cluster locally or remotely. And maybe you're needing to manage multiple container engines, say, for example, Lima or Docker or Podman all at the same time for VMs and containers, or you want to integrate with your existing Kubernetes tools like Kind and Minikube, or the remote clusters that you're already authenticated to with your kubeconfig. But for me, the biggest reason why I care about Kubernetes, about Podman, and I think why you should care about Podman too, is because of the spirit and community that open source software provides, a way for me and you and our partners and our competitors to all be able to work on something and to move software forward, to be able to create issues and create feature requests and PRs and contribute new features to the technology that we use every day. So that's just a bit about why you might be using Podman and why I think you should use Podman. But again, today we're going to be covering what's Podman, and just a show of hands, how many of us know about Podman or are already using Podman? Awesome. And any of us already using or heard of Podman Desktop? Okay, lovely. This is really good to see. So because of that, I'll kind of quickly go through the container tech refresher. If you haven't already used Podman or you're still new to container technology, then we'll talk about what makes Podman different, for example, from other container engines like Docker. And then we'll go into some really cool features that you might not already know about Podman itself. Before we go into the talk about Podman Desktop, show it off a little bit, go through a demo of working with a multi-container application, moving it through the different stages of container to pod to Kubernetes, deploying that. And I'm guilty of this sometimes. When you have to leave a session early, you don't always get the slides and resources. So I'll go ahead and do this right now. On my website here, we've got different links that I've curated for working with Podman and Podman Desktop, some videos that I've done for explaining things with a whiteboard, and also different articles that I've curated for working with Podman Desktop if you're a Java developer for things like test containers and build kits and stuff like that. And one of the articles is actually written by my friend here, Kevin, who talks about we're working with Quarkus containers with Podman Desktop. So a lot of good resources there as well as the slides. And without further ado, we'll quickly talk about Podman. And I kind of share this graphic here because the name Podman actually stands for Pod Manager. And a pod is, as I mentioned before, Kubernetes resource, one or more containers that are able to talk to each other on localhost. So they share the same networking. Multiple seals here we see, you'll see them around the project. A group of seals is called a pod, so that's where the name comes from. And I myself, I'm from North Carolina, so I can poke fun at where we are now. You probably flew into, Atlanta Airport. The SEALs probably came in there too. The MARTA was down, so they might have taken an Uber, got stuck in the traffic on the freeway, but they made it for the game to drink some cheer wine, to get some Chick-fil-A, and maybe they're going to go to Waffle House after the conference today. So that's my Atlanta starter pack. But coming back to the topic of containers, as I saw before in the crowd, some of us already have experience using Podman and Podman Desktop, but I also kind of want to gauge where we are at the stages of understanding container technology and Kubernetes as well. So raise your hand if you're a beginner, you're just starting writing your own Docker files, you're understanding the different concepts, building, pushing the registries. Okay, awesome. Raise your hand if you're intermediate, you're working with multi-stage Docker files, you understand container networking, you're working with Composer Kubernetes. Okay, awesome. And then raise your hand if you're advanced, you understand the different container runtimes, you're working with security practices, CI/CD pipelines with your containers. Wonderful. Okay, great. So that just helps me kind of shape the next 40 minutes here. So coming back to Podman, right? It's a tool just like Docker to be able to work with images, containers, which are the running process of those images that encapsulate our application, pods, which is a resource that comes from Kubernetes itself, volumes for storage, networking, and a variety of other concepts. But what you should know, and I hope that you take away from this session, is these 4 bullet points about Podman itself. And a little bit of history before we hop in. It came out in 2019. It's a project supported by Red Hat, but you can go to GitHub and view the source code and create issues and PRs, whatever you'd like. So it's a very open project that we have, and it's been rapidly increasing in popularity this year, which has been awesome. More opportunities for me to talk about it. So firstly, it's fast and light. What does this mean? Well, daemonless is what we typically say when we talk about Podman. So there's no background process that's going and creating our containers. What's happening is Podman works in a fork exec model. So Podman is forking itself on the Linux kernel, and then that process then becomes the running container. And we'll talk a little bit about the architecture here in a little bit. And you're probably wondering, what does fastest technologies mean? I get that's a little vague. But 2-3 weeks ago, Podman released Podman version 5, which are any of us using Mac? Fantastic. So now instead of using QEMU, I'll make this a little bit bigger. Podman uses the native Apple hypervisor. There's a lot of improvements for speed and stability if you're working with containers on a Mac. Of course, there's support with Podman for Windows and Linux as well, as containers are Linux. But I just want to make that plug there. Definitely check out the website and release notes if you're interested in learning more about that. So it's a daemonless container engine, and it's also a secure by default container engine. So this means from Podman 1.0, there's been rootless support. So I myself on a system without root access, I'm able to create containers. And what's happening is we're actually having a mapping of my user ID to the container as root on within that container. And I'll show a quick example of that here. So let me do get my user ID here on the system. And so if I do a Podman run and I'm going to call the universal base image, which is just a containerized version of RHEL that you can use freely, and list the contents of the user ID mapping. We'll see that the inside of the container, we've got the user ID of 0 being mapped to the host user ID of 501. And why is this important? Well, this helps with things like, for example, package managers and other applications that want to be able to run inside of a container on root, but maybe you're in an organization and you don't have that root access. So things like banks, things like financial services, large organizations that you can't give developers root or you're going to break your operating system or something bad. Here on the bottom left, Podman is a open by default open source project that's been around for since 2019, as I mentioned, as well as Podman Desktop, which came about last year in GA. And so what you're able to do is work with multiple container engines. As I mentioned, Lima and Docker and Podman at the same time. So there's no lock-in, and you can go on, view the source code, join the community meetings, join the Slack. It's a great community over there. And talking about other container engines, it's compatible and it's familiar with the syntax that you've been using. For example, if you work with Docker already, so a Podman or a Docker pull to get an image and to run that image would be a Podman pull and a Podman run. The syntax is very similar. If you have existing tools and scripts that already use Docker, you can link the Unix socket in order to not have to replicate those with Podman commands. And because it's an open source project, one of our community members wrote a script to be able to convert all of your Docker Compose to Podman and be able to use those interchangeably and keep all your Docker Compose because it does make some things easier. So that's a little bit about Podman, but let's go ahead and see it in action. I've got a little demonstration here on the right, but for the entire life cycle of working with containers, right, from being in VS Code to building an image with that Docker file to running that container, managing it, being able to debug it, SSH into that terminal, take that image and push it to a registry so I can share it with other people. We're able to do everything, including also working with Kubernetes. So working with pods and deployments and volumes to be able to run that YAML and generate that YAML from existing containers and pods. So that's pretty nice. I'll quickly talk about some brief container technology concepts here. So for images, it's just an encapsulation of various layers of our application in a tarball with some JSON. So I could take and export my container from Podman and import that to Docker and vice versa, and be able to run that on any type of system. So there's a lot of portability with containers. Here are some, with images, here are some commands here that are just handy to use. When we take that image and actually run it, that's a process known as a container. So it's the ephemeral version of your application running. If I close it out, everything is deleted and the resources come back to the host system. And so we can start it, SSH into it, view the directory, view the contents, and do anything else we need to do with the container. As I mentioned, Podman supports pods. This is one or more containers that are able to talk to each other on localhost, so you don't have to worry about IP and port mapping. And so what we're able to do is create a pod, add containers to it, export that, run that, and deploy it to a remote Kubernetes cluster. And so this is one of the big differences that we see between Podman and Docker. But you're probably wondering, what is the biggest difference? And this is a chart that I've created to kind of illustrate some of the architectural differences between Podman and Docker. So before I joined Red Hat or anything like that, I was working as a developer to use containers, and I would start a container, it would run, I didn't think anything more of it. And for a lot of us, that's how it should be. But I kind of started to uncover the different layers and look at the differences and why Podman is how it is. So we kind of learned from the lessons of Docker that we see here at the bottom. And so what's happening when we're creating a Podman container is that Podman is forking itself. We're using a utility called Conmon in the middle to handle logging and resource management. And then the runtime, say for example, runc, is then being used to create the container. And we have a running container as a process that can be managed with, for example, systemd. Compared to, say here on the bottom, what's happening is we're using Docker, say Docker Desktop, to pull down an image or run an image as a container. And what's happening is we're making a call to Docker-D, which is the daemon process running in user namespaces as root. And then that's, again, using the runtime. But this is kind of a security concern for organizations that can't be giving users access to root or to be able to view different logging of different container actions and be able to track that and audit that. And it's just in general a security concern. But if you want to learn more about this, I have a really cool video I've created, or not me, this is a great engineer, a 10x engineer, since my boss is in the room. On the left that you can view, it's a whiteboard video about some of the differences, use cases, and more cool information there. And then on the right, Christian Lempa has a cool video going through the pros and cons of both Docker and Podman. So definitely check those two videos out. They're linked in the presentation and on the website as well. I want to talk quickly about a couple other cool concepts that you can do with Podman. So not just compose and working with multi-container applications in our Docker Compose YAML files, but also being able to work with the Docker socket replication and use all of our existing toolkits and tools with Podman without having to do any configuration. And then WASM. How many of us here are using WASM? Okay, not many. I do want to show something really cool with WASM because I've just started looking into this. There's a project that Cloudflare engineers worked on where they did a port of Doom over to WASM, which is really cool. Someone went and containerized that, and I just want to show this because it's a cool example of what you can do with containers. So let me look for the image here. So someone already created the Docker file, containerized it, now it's an image. I'll run it here. I'll do the port mapping with Podman Desktop. I'll give it a name of Doom. It has a command to start when the container is running, and I'll start this. And so this is just a quick example of WASM inside of a container, but if I open this up, bam, we've got Doom running in our, let's see, I haven't played this in a while, or ever. But yeah, to be able to play Doom inside of a browser just like that because someone has already done the work to create the project, then instead of having to do all the commands to build that and run that on my system, I can just run that container. So lots of cool stuff that you can do with Podman. If I had time, we'd play Doom, but meet me at the booth. So this kind of brings me to Red Hat's container philosophy and why we help build these tools and what you can do with these tools. So our perspective is it's better to do a Swiss Army knife of different tools that you can use for all of your different container workflow. So we believe there's no one-size-fits-all solution, but we believe that as an open source company, you need to be transparent about what you're doing. You can view the source code, you can join the meetings, and you can help contribute to the path of where these tools go, which is pretty neat. And this leads to innovation and stability and security and a lot of other features. So not only do we have Podman and Podman Desktop, which we're talking about today and we're going to demo, we've also got Builda, which is a tool for building OCI-compatible images, being able to do a lot more features than just Podman and use that in your CI/CD pipelines. Scopio, say if I've got an image in Docker Hub, I need to pull that and move that somewhere else. I can do that without having to download it to my local machine. I can also compress, do different signing, and crun, which is an alternative to run C that we typically use. So for different edge cases, it has a 50% less memory footprint, which is pretty neat. You can check out the benchmarks online for that. But not just for development, but also for deployments and production, Podman is really neat because of the tight integration with Linux features I've been talking about. So systemd and C groups, not C groups, but SE Linux and seccomp profiles we're able to tightly integrate with. And so for example, if you have a systemd service, you want to containerize that. It's a lot of work typically. You have to write entry point scripts. It's a big headache. And say in the Docker file, if you put systemd or init as the entry point, Podman will set up all the mount points and requirements so that you can run your systemd service inside of a container. But that's for inside of a container. If you're outside of a container, you can use systemd and a feature known as quadlet to be able to kind of control and manage your different containers just as processes, right? Because that's what they are at the end of the day, containers. And so you can easily generate this kind of systemd looking file here in the middle to be able to define an image, volumes, restart policies, a lot of different features, and control your containers just to system to units. And I know I'm kind of moving into sysadmin stuff, so if you want to learn more about that, go to redhat.com/sysadmin, and you can learn a lot of cool stuff from really talented people. I wish my chart would show up here, but for things like auto updates and IoT, embedded, automotive use cases, you're able to, instead of having to do a pull, restart that container image, and SSH into these machines, you can just use auto updates to handle that for you. So new updates, security, patches, you don't have to worry about not having access to your systems, as well as rollbacks. But that's kind of my spiel about Podman. What I want to talk about, especially for the rest of this presentation and focus on, is Podman Desktop, because this is, I think, an absolute powerhouse of a tool for developers like myself to be able to work with containers, just as we've been doing and that I showed you earlier, but to craft applications to be deployed onto Kubernetes and give you all of the toolkit and the learning opportunities to be able to master Kubernetes. Because I agree, it's a daunting technology, but Podman Desktop is a great way to start learning and be able to craft your applications and minimize some of the discrepancies between your local development environment and where you actually deploy your apps. And this kind of brings me to the issue and the reason that Podman Desktop exists as a project. Because in the world of cloud native development, there's a lot of issues going on, and I kind of encapsulate it in this quote right here, that local development environments have become impractical. So the places where I do my coding and building and testing simply don't match up and lack consistency with production, where we're actually deploying our applications and staging. And there's a lot of different issues going on. So things like the registries we're using, the way we're crafting our applications. If it's in Docker Compose, my ops team is going to have to translate that into Kubernetes YAML. There's a skills gap. There's a resources gap. So the RAM and the CPU usage I have on my computer doesn't match up with where I am deploying my applications on production, and I can't really replicate those issues back on my local development machine. I'm not really a numbers guy, but we have 2 reports that 70% of IT departments in their whole organization only have one specific team that is an expert on Kubernetes. And raise your hand if you agree, Kubernetes can create conflicts. It can be difficult sometimes. So this kind of has led us to the point where we've helped kind of foster the creation of Podman Desktop. And some of the challenges I kind of like to illustrate here in this graph, going from a local development environment, as I'm going to be doing today, and crafting our applications to be deployed onto production. So say I'm a developer and I'm working in my inner loop processes, building, testing, things like that. Well, I'm working perhaps with different base images from the Docker Hub that I'm pulling that might have little or no security or CVEs. I'm working with Docker Compose, which is great for multi-container applications, but not necessarily as great if I want to deploy it onto Kubernetes, right? Working with no binding with managed services versus Kubernetes, that's where it might already be. And on the other side, our operations team is taking the artifacts that I'm working with and having to convert those to be deployed onto Kubernetes, right? They're working with their own carefully curated base images. They're working with rootless containers by default. They're working with Kubernetes YAML, which I don't really have as much experience with, perhaps. And this is kind of an adoption barrier because of this wall of discrepancies. And so the goal here is to be able to take Podman and Podman Desktop to simplify the workflow of going from my code to containers, pods, and then ultimately to Kubernetes, and bringing together the right side a little bit closer to me as a developer so we can minimize some of those discrepancies that exist, right? And to be able to share our application today on a remote Kubernetes cluster with OpenShift, which is the Red Hat distribution of Kubernetes that you could trial if you want to follow the demo repo that I have linked on the website. So before I kind of do the hands-on part, I kind of want to talk quickly about Podman Desktop. It's able to set up and manage the Podman VM for you to be able to run those containers as they are Linux processes. You can work and create pods directly from the existing containers you have, work with enterprise features for VPN and proxies, and then you can bridge to your remote Kubernetes clusters that you're already authenticated to with your kubeconfig, which is pretty neat. So Of course, what we'll be doing is working with a pod today, so it's a 2-tier application that we're working with. Unfortunately, I didn't have the time to rewrite the whole application in Java, but my intern is working on that, so should be done within a year. We'll be also working with images, creating images from the Docker files that we're working with today, pushing that to local environments like Kind and Minikube, and then being able to deploy those remotely, as well as view the different resources that we have in our cluster. So the team, because of KubeCon last month, put in a lot of work to be able to view different Kubernetes resources that you have on your clusters that you're connected to, right, from your kubeconfig already. So be able to view the different contexts, be able to view the different deployments, services, ingresses, and be able to manage those as well. So be able to update those directly from Podman Desktop. And we'll go through all of this in the demo. And then finally, I'll talk about the extensibility. So Podman Desktop is kind of what we view as a way for you and everyone in the community to be able to take it and adapt it for your use case. So it's written in Electron, and you're able to create JavaScript apps to be able to extend the capabilities. And we'll talk about how it was created later on with the different stack components. But for example, the Minikube extension was actually created by someone in the community. And there's a lot of other PRs that we're waiting to review for different features for Podman Desktop. So it's kind of a testament to the power of open source development. But let's get into the demo. If there's any questions thus far, I'd love to help answer. And we'll spend most of the rest of the session going through this application that we're working with, deploying it to Kubernetes, and then we'll kind of wrap up with some more resources. And all of the code that I'm working with today is in the website and the repo that we have on GitHub. So feel free to check it out and try this demo on your own time as well. So what we're going to go ahead and do is start out with the most, oh, sorry?
Yeah, can you compare Podman, do a comparison of Podman with Rancher Desktop for Windows, or would that be too far away?
I can kind of compare it, but for Rancher, Rancher is more for their kind of distribution of Kubernetes, and Podman is kind of for any type of Kubernetes cluster. Like we're supporting OpenShift here. You can support, if you're connected to any other cloud provider's cluster, be able to easily go between different cloud providers, right? And Rancher kind of has, I believe, a premium model, enterprise version.
No, Rancher Desktop for Windows is a replacement for Docker Desktop for Windows, but they guarantee that it will be permanently license-free.
They guarantee it'll be permanently license-free? Yeah. Okay, yeah, sorry, I thought there was, because Docker Desktop has the $5 per user per enterprise.
Yeah, that's a common confusion, but basically they promise that they will never charge for it.
Well, that's good, because that was a big issue and a big reason for the growth of Podman Desktop is because all those users had to migrate off, so they went to Rancher and OrbStack and Podman Desktop, which we're showing here. So yeah, I'll continue on with the demo here. So I'll go ahead and close off this Doom container and delete that, as we're going to be using that port 8080 for this example application. So this is Podman Desktop here. I'll make it a little bit bigger. And this is the most recent version. It's not on Podman 5 yet. They're about to update that. But we can see we've got management for the Podman engine itself to be able to install it, configure it, set it up for you to use, keep it up to date. We've got a connection to the developer sandbox, which is how we're going to deploy our application for it to be sent in the Devnexus chat so other people can see it. We've got a cool learning center for different guides and learning paths to get started with Kubernetes and different Java frameworks, so Spring Boot and Quarkus and maybe Python and other languages as well. And then some connection to extensions, so if you want to use Lima or Docker, you can use the extensions there to be able to work with your containers in Podman Desktop as well on those engines. What we're going to go essentially and start from is the images section here, where I've got all of my different container images. And here I have the code from an application. So I could work with the CLI of Podman, right? I could memorize a lot of different commands, all the different tags and parameters for tagging images, and anything else that I'll have to do with my containers, or just go directly from, and I'll show the Docker file here, the build section of Podman Desktop for the images. We also have options for loading in images, exporting those, and pruning any ones that we're not using as well. So I'll go ahead and build this, and I'll show off the Docker file here. So this is a multi-stage Docker file. We're working with the universal base image for Red Hat Enterprise Linux to install all the runtime tools, to set up the file system, to install the dependencies of the application on top, to copy the application, create a non-root user, and then finally start up that application with a command to run. So we've got the Docker file there, and I'll go ahead and browse for my directory here. I'll go into, let's see if I can find this, front end, cool. So we've got the Docker file here. We can specify the Docker file or container file as well as the path of my directory. So say I'm working in a Java project, I'll probably have to go back, say for example, if it's Quarkus, to the root directory of this project. And I'll name it here. I'll tag it for my registry. So we're using key.io, which is an alternative to Docker Hub. But you don't have to worry about the rate limiting, which is nice. Devnexus. Okay, cool. So we'll go ahead and build it for architecture. We see the steps going on there. We're copying in the directory that we're using for the project. We're doing the building of the image, and finally tagging that so that we have the image here once we go back to the Podman Desktop Images section. We can see the different layers of the image. We can edit it, tag the version. If we're doing that, we can push it to a registry. So I could do that here. But what I'm going to go ahead and do is also pull Redis. So this is going to be the cache that we're using for our application. We can see that in the actual code here. That super simple. It's just a hit counter with a bunch of different resources for Podman Desktop to connect to Redis and count how many times it's been used. So we already had Redis, fortunately. And so if I go down and I search for that image, I'll go ahead and start it. There's a whole lot of different parameters when we're working with Podman Desktop and Podman in general to be able to specify, okay, here is the volume I want to use, here's the port mapping. It'll automatically make sure that we're not using an existing one. The entry point, it looks like I already have a Redis here, so let me get rid of these two. And I'll go back and restart that process of starting the container. We also have options for networking, advanced features, say if I want to add host or DNS servers, and also security features if you need to work with that as well. So I'll go ahead and start this, give it a name of Redis. The container started just like that. Now we have a Redis instance running on our system. We can view the logs, inspect all the details about the container, view the Kubernetes manifest here for a pod. And now this isn't really interesting right now, but when we combine it with more parameters and other containers if we have to, then we're able to see some pretty cool manifest here in this section as well. A terminal if we want to use, say for example, the Redis CLI. And I'll actually take the IP address here, down here to be able to provide that for the Python application. So we specifically wrote it so that it would take it from the host file and be able to use that when it's starting up to connect to Redis. So I'll go back over here, the Devnexus Python application that we just built. I'll call it Python app. We don't have to specify volumes. We're using port 5001 automatically because port 5000 is airdrop. And I've had that problem before on a live demo. Wasn't fun. And I'll go ahead and create this other container. So we've got the Redis container working as our cache, and now this Python application so that we can refresh and view how many times the application's been opened and check out some cool links as well. So that's kind of working with multi-container applications, super basic things that we're already used to. But the next step is going and creating a pod from both of these containers. So what this is going to do is it's going to stop both of these containers running. We'll be able to give it a name. So I'll call it dev pod, and we can specify which ports we want to expose. So I'll wait for this to start, and we're stopping those other two containers, and we're reproducing them within a pod so they can talk to each other on localhost. And then we can take that, and we just have a little issue about OCI runtime error. I don't think it should matter. Here we have oh yeah, we've got the containers starting up in this pod here that we're running locally on Podman. You can see if you're running in a Kubernetes environment or Podman itself. So I believe Redis should be running as well. Okay, so we have an issue with Redis. Let me see if I can debug this live.
Maybe you need to delete the previous mount that it has or the previous Redis.
Yeah, I think that's the issue. Let me see if deleting Redis itself would do that. Well, fortunately, folks, I have a backup. So this kind of brings me into the extensibility part of Podman Desktop. So we've created here within the repo. So I'll look up extension. So as I mentioned before, you can extend Podman Desktop with whatever type of extension. You can also use Docker Desktop extensions. We've got this Node.js application that we've Docker filed, and we can import it into Podman Desktop as an OCI image to essentially do all the tasks that I was just supposed to do here. So to check out if the images exist, to clone those, and not to clone, but to pull those down. And so if we go back over here to Podman Desktop, we see I have this little tab at the bottom here. So all I had to do was go to extensions and install a new extension. And as we can see, I've got this one here already. So now, fingers crossed, if I delete this pod existing already, and I clone in these two new images, fingers crossed that'll work. But this is kind of just showing you can extend Podman Desktop however you'd like. So what it did here is now we've got two new images from key.io Podman Desktop demo for a backend and a front end. The backend itself is just Redis, but built from our own image. So we're taking Redis and we're installing it and we're running it, so we don't have to use a version from Docker Hub. We can create it ourselves. So now if I try this again, fingers crossed, to create the pod, we should be able to see it running in a pod on Podman itself. So then we'll take that and we'll actually deploy that onto Kubernetes, so we can start testing and playing around with that inside of a Kubernetes cluster. Bam. All right. Whew, demo gods. So we could see there's 3 containers running. Those 3 containers are the infra pod, and then the 2 containers that we've just been working with. We can view the logs of all of those here. Oof, we got the Python app, and we have the Redis database. And if I open this up, bam, they've restarted, so the hit counter has been reset, and we can refresh that and view that there. But let's also check out the Kubernetes manifest. So here we can see that we've got the back-end image, and we've got the front-end image. And it's all cool to be able to work with that from here. But what I want to be able to do is to be able to start doing some testing. Oh, that's the Docker compatibility. But some testing within a Kubernetes cluster locally before I take it and take it to staging or a production environment on my actual remote cluster. So what I've done, and I'll go ahead and do this again here live, is we're using some of the extensions of Podman Desktop. So this one is the kind extension. So integrates with the kind utility to be able to create clusters within a container. But we also have support for Minikube, which is single node Kubernetes running on your system. You'd use Docker or Podman. You could set up where the port will be for an ingress controller so that we can view our application automatically. And just like that, we're going to be using Kubernetes 1.27. We're going to prepare the node, start the control plane, and we'll have Kubernetes running within a little containerized environment here on Podman Desktop. So give that a second. We've created it. And we've got the control plane running here inside of, and we can view it inside of Podman Desktop, do our kubectl commands. So I'll take this pod, right? It's running here within Podman itself, all good and well. And we'll go and deploy this, but not now to Podman, now to a remote or local Kubernetes cluster. So we view the Kubernetes YAML we're working with. We can automatically create that ingress to be able to view the port that's being exposed, and we'll go ahead and start the creation of that pod. So we've got the 2 containers within that pod that are being pulled to now run within this local Kubernetes environment. Hopefully the internet will do me good here, and we'll be able to view that here in a second. But say if you're deploying to OpenShift, you're able to automatically create those OpenShift routes to be able to share your application, and so that's pretty neat as well. If you need security context, you're able to work with that there as well. We'll give it just a second here. Bam, both the containers are running within that pod. So if I go back here and do kubectl get pods, then we can see both of those are running, and we can also view those on port 9090 where that ingress was created. So it automatically does the mapping for us. I didn't have to worry about ports or anything like that. I just want to, as a developer, focus on my application. What I also want to do is show kind of Minikube very briefly. So here we can create and work with a Minikube instance, but in the interest of time, it takes a few minutes to start that up. And so I will come back and show off both the pods that we have here and the Kubernetes UI. So we've got the services created already for that ingress. This is because we've got connection with that kubes config on our machine to be able to view that. And we've also got the ingress that's been created as well. But what I want to do is apply some YAML to this Kubernetes cluster to kind of mess around and try some stuff out. So what I did yesterday was I created a change in this file. I said, instead of hello world, I said hello Devnexus, and I rebuilt that image. And I created a quick and brief YAML here in this repository. Let's see, show in Finder. So it's a deployment, and we've got both the containers that we've been working, or the first container we're working with for Redis, but I've changed it to that new container that I pushed to a registry. And we're creating a replica set for one replica of this new pod that I want to deploy into the cluster. So we've applied that resource, and what's going to happen is the new deployment will now be provisioned inside of this cluster, so we can wait for the pods to be instantiated and view that from, if I go back here, the control plane. So if I do kubectl get pods again, we can see now we've got the original dev pod that I deployed here. Yes, sir.
Yeah, I just had a question. So I guess the icons on the top left, those are like, container, image, volume, or whatever, that kind of stuff. But the ones that are slightly like highlighted, those are Kubernetes controls. Is that what you're saying? Because like the application of the YAML that you just did without having to go into the CLI and do like kubectl apply dash whatever, doing it the YAML. Did you just do that through one of those tabs on the left or something?
Yeah, you're talking about these?
Yeah.
Okay, yeah, sorry, I should have minimized that. But yeah, so that's all the Kubernetes UI functionality. And if you don't already have kubectl to do that, it helps guide you through that installation.
But you can't apply the Kubernetes files directly from Podman Desktop. You don't have to go to the CLI to go.
Right. Yeah, so you don't have to context switch back and forth between terminal and.
You like say went to your terminal and like swapped to your dev cluster or whatever, you updated your config, and then you came back here, would it then be connected to that one and you would be able to make applications to your dev environment or whatever?
Yeah, you took the words out of my mouth. Exactly. That's the process that we're like going for with Podman Desktop. So now if I check, I had those two. Let me see if I do a kubectl describe pod, and now. So the dev pod itself is just those two. Let me see. Well, let me autocomplete. Let's see. It won't. That's all right. If I go over here to, again, the ingress for this Kubernetes cluster, refresh it a couple times. There we go. So we can test between those two different pods that we have running on our cluster there without ever having to leave Podman Desktop, which is pretty nice. And so this is kind of an example of doing some different testing on a local cluster really briefly. And the final step here, as we kind of close out the session, is now I have this pod running, and we've got the resources and YAML to work with it. And now I want to take it and I want to share it somewhere. So what I'm going to do is create a new developer sandbox instance. So if you haven't heard of this before, this is a essentially free to use OpenShift cluster with 14 gigabytes of RAM and 40 gigabytes of storage to be able to do some testing and development and no Bitcoin mining, even though it's skyrocketing right now, of our Kubernetes, of our applications onto Kubernetes. This is in, you can learn more about this at the booth, but I'll just quickly start up this cluster. We're going to authenticate it like any other Kubernetes cluster that we would do. So I'll go ahead and launch OpenShift here. You've also got stuff for if you're a data scientist to work with different models. Right now it's down, but we anticipate it'll be back, and as well as the IDE, VS Code in your browser. Pretty cool. And so I'll connect to that here. All I have to do is give Podman Desktop the token. So I go here, copy the login command, and we're essentially going to go through that same flow that we did with the local cluster, but now to a remote cluster that since I've done some testing and everything. So come back here. We copy in the login command. I set it as the current context. Oh, I already have that name, Devnexus. So I'll create that there. Now we have a new kube config context. So this new Devnexus. I'll take this pod that we have running, and I'll go ahead and deploy that now to this OpenShift cluster. And so hopefully it'll be a lot faster with the creation of these two containers. And we'll be able to easily reach this route using the connection directly from Podman Desktop. It's automatically generated. And now, bam, we refresh this. We've got this, this application now that we've been working on locally. Now it's remotely accessible, and I can go over to, let's see, I'll go over to the Devnexus Slack. Who here is in the Devnexus Slack? Okay, not many people. Howdy, here's my test app. If you want to check it out, here's the application. I can share this with other people. I can do some testing on it. And that's the beauty and the flow of using Podman Desktop. So I'll quickly finish off with a couple slides and some behind the scenes. So we've built this with Electron, same as Slack and VS Code, using Tailwind. That's why it looks pretty and svelte. If you're working with Windows or Mac or Linux, you're able to use these different virtualization stacks, native hypervisors. But I kind of want to talk about what's next for Podman and these projects. So as I said, there was that V5 complete rewrite for the Mac hypervisor to be able to create those VMs that run the containers for you. There's a lot of other improvements that are on the way, but the team needs probably to rest for a little bit now. Feel free to like or start the project on GitHub. And for Podman Desktop, there's new flows for onboarding, for the Kubernetes Object Explorer, as I just showed, and OpenShift support for an image checker, and more if you happen to use OpenShift. So my call to action to you, my request is if you haven't already used Podman, learn how to use it at podman.io and podman-desktop. We've got a lot of guides and a great community around there to support you throughout that process. If you're on the Kubernetes Slack, feel free to join our channel there. Check out the GitHub for both the projects. If you have an issue, we'd love to help. And the maintainers, just like Quarkus maintainers, are very active on there. And get involved with the community. So there's a lot of different chat environments. You can chat with the maintainers of the project, and you can submit issues, anything like that. Again, if you didn't get those resources for the demo or the tutorials or anything like that, here they are for the slides as well. And I also want to point you to the developer sandbox I just used to be able to deploy my application for free onto Kubernetes without having to stand up my own instance. 30 days, but you can renew that and keep using it forever to mine Bitcoin. There's also a lot of courses that I maintain on the website for Kubernetes, GitOps, pipelines, Tekton, Java, Quarkus, everything. We have a lot of courses that you can do for free. They're self-paced. And again, that's the link to join the program, to get free ebooks. And I also want to point that we have the Podman in Action book for free, hard copy here at the booth. So pick up one of those if you're interested. And I'm working on writing the Podman desktop book here. So maybe by next Devnexus we'll have that. But I want to thank you so much. It's been a pleasure. And thank you for your time.